my name is Fernand Silva, and I am one of the team's aerospace engineers and project lead of the SAR Black Team UAV, now named S.P.O.T. From the get-go with this project, we as a team knew that we would not get anywhere unless we had an idea of a baseline to work against. With this in mind, my teammate Jenna and I were able to secure interviews with two people knowledgeable in the area of search and rescue drones. Those two people being Mario Worth, business owner of a defense contracting company that specializes in drone deployment, and Corporal Matthew Drennan, a first responder with 7 years' experience as a UAS operator under the Lake County Sheriff's Office. I will let my teammate introduce and go over what we learned from Mr. Worth, but here's a segment from our meeting with Mr. Drennan.
Top things I'd want from a search and rescue drone would be something with a good battery life, a good thermal camera, something capable or being able to zoom in and look at things, having a big screen to be able to see what I'm looking at on the ground control station, and then maybe something capable of automated flights where I could kind of just put in a search area and then have it conduct an automated flight, and I could kind of control how fast the drone goes, stop it, start it, and I could zoom in on certain areas.
From these interviews, the team has gathered that some of the important aspects of a drone dedicated to SAR operations needs to be a UAV that has the ability to be quickly deployed anywhere at a moment's notice, that is cost efficient to allow for wider application by first responders, and is able to reliably achieve a longer flight time than competitors. We as a team have achieved this via designing a tail-sitter design UAV that begins flight as a VTOL drone that then transforms to a cruising flying wing after launch. The drone is also equipped with an FPV-style camera at the front for target acquisition. With calculations done, the UAV created is prepared to achieve a total flight time of 50 minutes.
Hi, my name is Nicole Schricker, and I'm an aerospace engineering major on the SAR Black Team. Baseline CFD was performed and ANSYS Fluent. 3 profiles were analyzed: the Selig S1223, the Martin Hepperle MH45, and the NACA 4424. The S1223 airfoil produced high static pressure beneath the wings, favorable for lift, but its limited thickness would require a separate electronics bay. The MH45 showed lower subwing pressure, but similarly insufficient core thickness for the internal packagings of our UAV. The NACA 4424 was subsequently selected. Its 24% thickness supports all of our internal packaging with plenty of room to spare. Its thicker nose and moderate camber offer predictable lift and smoother stall. I was designated the Scrum Master for this project, where I focused on keeping everyone's tasks up to date and accounted for. I updated our Microsoft Teams board with new tasks and made sure that my teammates were utilizing the board to their advantage, keeping track of their own tasks and retaining accountability within our group.
Hello, my name is Caden Tagner, and I'm one of the team's mechanical engineers. During our pre-analysis for what FCs we were going to use for our UAV, I looked through many different options that varied by cost and reliability to determine that the Pixhawk 5X controller was our best option. Some other choices I looked through included the Navio 2, DJI Naza MV2, and Naze 32 flight controllers. Although overall, the Pixhawk was a great controller for its extensive modularity, moderate cost, and safety redundancies. I also CAD'd some of the pieces we needed for things to run smoothly. I CAD'd the original rib design we had for our UAV up until we changed the airfoil due to power consumption and other flight issues. I designed the legs for the tail sitter while keeping structural integrity in mind via adding a hole for weight reduction within the design. I also designed the servo horn for connecting our servo to the elevator/aileron for the tail sitter. During the building process, I dremeled our carbon fiber rods into smaller separate pieces. I assisted with gluing and monocoating the UAV, as well as enabling strong structural support throughout. I also soldered wires needed for our ESCs on the electronics board.
My name is Jenna Watts, and I'm a mechanical engineering major on the SAR Black Team. Our material selection focused on creating a lightweight yet rigid and field-durable airframe for search and rescue missions. We use a combination of balsa wood and carbon fiber for the mainframe, and then PLA and ABS for additional components that are 3D printed. Carbon fiber is used to maintain the shape of the UAV and reinforce load-bearing areas like the wings, since it offers excellent strength while staying lightweight, helping reduce flex and vibration. The balsa wood form the mainframe, reducing overall weight and improving flight endurance without sacrificing rigidity. Working with balsa wood, we noticed the grain of the wood mattered, depending on if the force was perpendicular or parallel to the grain, affected how rigid or how flexible it was. We used this to our advantage, though, for when we needed to bend the wood, like for the front of the UAV, versus using it for structural purposes, like for the ribs. Components 3D printed from PLA and ABS were used for motor mounts, landing legs, and fittings for precision and strength were important. Altogether, these materials give us a solid balance between weight, durability, and stability. In the interview with Mario, he discussed how important it is to match motor power, ESCs, and battery capacity to the drone's total weight. He also mentioned using materials such as aluminum, foam, and using epoxy and fiberglass for the UAV's body. We strayed away from these options because of their price and their difficulty of use.
So, what we do at UAR is like foam and a lot of, composite is kind of what we do, right? So foam is the easiest way to do it because you can literally just get the pink Lowe's foam, the one with the Pink Panther on it.
Yes.
And that's a lot of our first time prototypes before we start, committing to carving out blue wax is we just use that pink Lowe's foam. We glue several sheets together and then we get sand in.
He also mentioned how temperature and vibration can affect both printed and structural parts over time. To account for this, we allowed for hollow space in the UAV to allow for convection cooling for the electronics. We then use hexagonal filling with 3D printing to decrease vibration and improve the strength of those parts printed. His input guided us to select the materials that were best suited for us and refine power to weight balance, ensuring the drone performs reliably under some real-world conditions.
Hello, my name is Adarsh. I'm the manufacturing lead for SAR Team Black. This is our drone. We have our two main puller props in the front, our two flaps here that are servo controlled, and the internal hub which houses all the electronics. And then our two sides are our stands to hold it up during our VTOL launch. Additionally, we have a camera up front, and we have the antenna and receiver in the back. Okay, my main responsibilities for this project were the assembly and design. So starting from the CAD of the nose, the whole shape of the wing, all the way down to the tapered edges, as well as the stands. And then from there, I took those DXF files from the CAD, turned them into laser cut patterns onto balsa wood, which made up each individual rib along the full length of the wing, and then mirrored on the other side. And then also the assembly of the carbon fiber rods, holding it all together for a structural integrity. Additionally, I manage the code and motor settings of all of the electronics within. This includes setting up the antenna and receiver, pairing it to the controller, and pairing that to the computer to act as a ground station. Also managing the flaps and general positioning, so managing the speed control, the altitude control, roll, pitch, and yaw control as well. And that was all done within the Pixhawk.
Hello, I am Brooke Ferrera, and I am the mechanical engineer who worked with SAR Black Team develop S.P.O.T, our UAV. Some tasks that I helped with were the procurement engineering needs. Procurement engineers are those responsible for finding, buying, and in this case, the maintaining of materials. They find what products are needed for assembly, doing research into who can manufacture the parts, or finding competition as budget is a constant concern and constraint that they keep in mind. They then buy the part that meets the budget and time constraints and makes sure to keep track of all the parts throughout the whole process. Procurement engineers' main goal is efficiency and effectiveness of the acquisition of parts. Procurement engineering
During testing,
objectives
we ran into
were
the issue
maintain
of our
budget,
weight being much
source
larger
parts,
than our
find
predicted
cheaper
weight.
or usable
This
duplicate,
occurrence showed
order
that a
parts
more
required,
thorough design
track
evaluation
ordered parts,
and more rigorous motor testing would need to be done to prevent any future instances of this. What we learned during this testing included the importance of motor testing, airfoil analysis, weight calculations, component reliability, and overall preparation of flight day. Changes that we would make. Changes that we would make. Testing the motors more frequently and sooner, creating our own airfoil that meets the needs and demands of our requirements, have more thorough and fleshed out design before building to know the true weight to be expected, manufacture components, and use different materials to reach our design structural integrity. In the future, the ideal would be each part and component be analyzed in ANSYS or SolidWorks instead of just the main concerning parts. A higher quality FEA and overall fluid air analysis for the aerodynamics to allow better control over the outcome of the UAV. Honing down our UAV design earlier in the process instead of switching midway through could also help prevent our UAV being overweight.